Several of you have mentioned that you had some serious problems with the questions on this tutorial, and so I'm going to step through it with you since we've already done it, and you can go ahead and redo it if you have not done it already and been unsuccessful in getting through to the end. So let's go ahead and fire it up. This is your starting screen, and I'm going to click on ionic bonding questions, and you've read this screen before, so you don't need me to go through that. Now, check the box that best completes the following statement. Ionic bonds form when? Okay, so they become when an electron transfer creates two oppositely charged ions. Now, what's wrong with the other two? Two atoms come close enough to start sharing electrons. Well, the problem there is the word sharing. All right, this sharing business doesn't happen. Not with ionic bonding. That only happens with covalent bonding, which we'll be talking about in the next chapter. Now, when they say two atoms begin attracting each other's electrons, that's kind of a sucker punch too, because that is not what will form ions. This third selection is what they were actually after. So we've got to get rid of this little ink layer, and we'll submit the answer. And now let's look at this guy. Okay, on this question, they wanted to know, they want you to know if we have a positive and a negative, we will be able to form an ion. A positive ion is formed when the atom loses electrons, and on that first one where it says Na plus and F minus. Okay, sodium is a metal, and fluoride is a nonmetal. So a metal with a nonmetal is always going to form an ionic compound. And the calcium with the iron, calcium is a positive ion and iron is a positive ion because those are both metals. So that one is not going to work. The one with oxygen and sulfur, the last choice down there, again, you're talking about here two nonmetals. Now, sometimes nonmetals will come together to form ionic, or not ionic, but covalent bonds, and the oxygen and sulfur are one of those that do actually come together, but it will not be an ionic bond. It's a covalent bond. So we can go on to our next one. In this question, you're supposed to place these guys. Well, the charges are the same. If you miss this and you have to redo the thing for whatever reason, you might be also presented with two negative ball-shaped ions. Okay, so these guys have to be placed as far apart as you can get them. I like to put them down here in the corners, and let's see if it'll buy that one. I know if you go horizontal, it will buy it. And let's just go ahead and suggest what that will be. Yeah, okay. As far apart as you can get them. So if you just go horizontally left to right, that would have worked as well. Which of the following could not form an ionic compound? Check all that apply. Don't you hate that? Anyway, let's take a look at it. Okay, why do I have those two checked? Well, let's check out the first one. The lithium with chloride, that's a metal with a nonmetal, a plus with a minus ion, and that's the very definition of an ionic compound. The one on the bottom is magnesium and sulfur, and those are, again, are a plus with a minus, so those will form an ionic compound. Your problem with the F and the O2, the O2 minus, that is, the fluoride with the oxygen is not going to work as an ionic compound. Okay, they might form a covalent compound, but not ionic, because you have to have a metal with a nonmetal to get ionic. And with the barium and silver, those are both metals, and so they both form positive ions, as you see on the screen, but they are not going to be able to form any kind of a compound, because metals don't bond together. So that's why that's your answers there. Now, with number 4, which of the following elements will form positive ions? We again look to metal, nonmetal. So as I'm looking down on this one, I see for positive ions, we have to have a metal. So look at nitrogen, the N, that is a nonmetal. So we're not going to be able to check that. Look at the bromide at the bottom, or the bromine. Bromine will not form a positive ion. Okay, we're asking about positive ions. Now metals will form positive ions, so sodium is definitely a positive ion, and that's because he's a metal, and copper is a metal, and he'll also form a positive ion. And that's how we get through that guy. All right, next, which of the following elements will gain electrons to form an ion? Check all that apply. This is pretty much the same as our last question. And so, which of the following elements will gain electrons? The gainers are going to be the nonmetals. Now, neon is a nonmetal, but we don't want to check that. The reason we do not want that guy is because he is going to cause us grief because he will not form an ion. So we just get rid of him. We're not going to answer that guy. Zinc is a metal, so he's not going to grab electrons. He's going to let them go. And calcium is a metal. He is also going to let electrons go. We want a gainer. Well, fluoride, the fluorine ion, is the most reactive. Fluorine, the nonmetal, the element, is the most reactive element on the periodic table in the nonmetals because his electronegativity is the highest. So this guy's going to gain electrons, but he's the only one. This problem is essentially exactly the same as the last one. And which of the following will form negative ions? Okay, there's two nonmetals there. Okay, potassium, he is a metal. Magnesium is a metal, but sulfur and iodine are nonmetals. And so they will indeed form negative ions. And so we just hit those two guys and we're on our way. Now, which of the following elements will lose electrons to form an ion? Okay, the losers are always metals. So we just find where these guys are on the periodic chart. Now, phosphorus, no way, because phosphorus is a nonmetal. And selenium. Selenium is over in the nonmetal category as well. And then we have iron and lead, who are both metals. So those are our two choices here. Now this guy is kind of fun. What we need to do is we need to rotate this molecule so we can see everything that's there. And what they want is the smallest possible ratio of aluminum to oxygen. So aluminum, or the key on there, is at the bottom, and so you can see right down here the key that tells you that that guy is aluminum and this guy is oxygen. And so what we want to do is roll this guy, and now we want to look at him very, very carefully. We want to look at him first of all on this face of the molecule. You can see we have a total of, on the front side, 2, down below and above we have 2, so that's 4. And now if we go a little bit further, there we go, let's get that lined up again. Okay, we have 2 plus 2 is 4, and 2 more in the background. There, let's look at that again. Right now I'm looking at a total of 4 atoms. Now let's roll it down this way, and I'm seeing as I do this, it's hard to get it to stay put. But at any rate, this guy, you've got 1, 2, 3, 4, 5, 6. Got a total of 6 reds, that's your aluminum. And now the grays, as I'm looking around, you just got to look at it from all directions. Make sure you're getting what you're supposed to get. We had 6 aluminums, and we got 4, we had 6 oxygens, and we got 4 aluminums. So 6 oxygens divided by 2 is 3, and 4 aluminums divided by 2 is 2. You see, we might do the sucker one. That's the actual ratio, no question. However, the ratio can be changed by doing this. This guy and this guy can both be divided by 2, and that reduces the ratio to what you see just below that one. So we don't want that guy. We want to take him away. But this guy right here is going to be our choice. So we have to be sure of who's who when we do this so that we don't get the numbers backwards. And once we do get the numbers, we got to make sure that we reduce them. And that is your whole thing on this particular issue. So here we go. Next one is use the ionic crystal pictured below to choose the correct formula for the compound picture. Okay, so again, we want to hold on the screen and move our finger around to rotate this molecule. So I see a guy in front and in back, the iron. I see a iron front and back, and then I see 4 more irons. Okay, there's 4 more irons there, and 2 that are directly above each other. These guys, that guy and that guy. Okay, so here I am. I'm looking at the ion, and I'm seeing what it is that we're supposed to see here. We'll go ahead and draw this. So we're looking at this is 1, 2, 3, 4, and then over here we've got 1 in front and 1 behind. So a total of 4 plus 2 is 6. So that gives us 6 irons. Now we want to look at our oxygens. And this is a little hairy the way this molecule is made. So let's get something that kind of lines up somewhere. And let's go ahead and put our finger on it, so to speak. Okay, I see a red here, 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 and here, and also 1 in the middle. Okay, so I've got 5 that I have my eyes on right now, and as I rotate this molecule, let's put this back in motion now. As I rotate that molecule, I'm going to be able to see what's. I gotta get rid of the ink. There we go. Now, I'm gonna roll this back, and I can see now from this view, I see something different than I saw before. And let's get rid of this guy. Oh my, hold on. Okay, now we're rolling again, and I finally got this thing moving again. So now I can see reds. There we go. In this plane right here. Here we go. If I roll it this way, I see 2 on the bottom and 2 on the top in the center there. And then on the left side, I see 2. On the right side, I see 2. I'm talking about the reds now. And then I see 1 in the middle. So I've got 2 top and bottom, 2 left and right. So that is 4 and 4 are 8 plus 1 in the middle. And that gives me a total of 9. So the ratio here, and I touched that before I went ahead and made my choice. Well, what I was going to do is go ahead and click here, and when I clicked here, what that would give us is this guy. Now, for that guy, that is the ratio, but it's not the smallest ratio. So if I divide 6 and 9 by 3 each, the 6 divided by 3 becomes the 2 here, and the 9 divided by 3 becomes the 3 here. And that would be our correct choice. So I accidentally touched that submit button before I had everything set up right. So let's go ahead and go on past this screen And we get to look at another question. And whoops, I don't want to do that. Okay, let's go ahead and continue. And that gives us one more question that we get a chance to look at. And this guy I'm going to make a mistake on purpose. But first of all, let's look at it. See, as we rotate it, I see 3 on the front, and then I see 3 here that where they were on the back. Okay, front and back I have 3. So that's 6 of the bariums. And the reds, looks like we've got 3 on this face and 3 on this face. So we got, looks like 6 and 6. Okay, so if we have 6 and 6, that means that for 6 and 6 we have a deal like this. Can it be reduced? This 6 can be divided by 3, and this 6 can be divided by 3, which, oh, by 6? Yeah. So this is going to lead us, when we reduce it, to this guy. Divide both of these 6's by 6, and that gives us barium and oxygen, and that's our basic formula. So let's go ahead and clear the writing, and we should be able to get a correct one on that. But I'm going to click this one on purpose, because that would be an improper reduction, and I want to get another question out of these guys. So here we go. We'll get one more question. And they're going to keep showing us these things, I guess. So let's go ahead and do this one correctly. So I've got 4 here and 4 here of the bromines. Okay, 4 on this side and 4 on this side. And then I look around and I see 1, 2, 3, 4 of the strontiums. So it's 4 and 8. Yeah, 4 and 8. So 4 and 8 would make us think it's this guy. Can we reduce this? Yes, this can be divided by 4, and this can be divided by 4. So if we divide each of those by 4, we get 1 and 2, which is this formula here. There's a 1 here with the strontium that's not written, and a 2 with the bromides. So that would be our correct choice, and let's go ahead and get the result that everybody wants to get, and that is a correct answer, which makes it 10 correct and 2 incorrect. And we pass. And we are now getting recorded. So we return to the home page, and we have it all recorded, and we have gained the delight of having gotten it all right, or enough right to be able to pass. Hope this helps you.